Hello, good day. Welcome to Inherong Cowboy YouTube channel. Now we will be discussing about the construction cost engineering. Okay, so cost is very important in every project in engineering. Okay, so we need to manage the cost in order to finish our projects. Okay, so case 2, I am welcoming you to this subject, and I hope you will learn from my discussions about this one. Okay, so for now, let's go to our presentation. Okay, okay, so we have here our course description. Okay, so it tells that this course covers conceptual estimate of breakdown structure, estimated schedule, interface planning, earned value, detailed estimating, spatial estimates, and the use of estimating manuals. Okay. Okay, so course objectives. After completing this learning session, the student must be able to, number one, is to analyze the cost implication of project scope. Then number two, optimize the balance between cost and time implication of design discussions. And number three is the optimize the balance between cost and time implication of design decisions. Okay, then number four, we have to optimize the balance between cost and time implication of design decisions. Okay, so we have here our course outline. Okay, so the number one or the LS1 is we have the conceptual estimate, and number two is we have the parametric estimating. And number three is work breakdown structure or WBS. Number four is we have estimate or schedule interface planning. And number five, we have the earned value. And number six, we have detailed estimating. And number seven is detailed estimates. Special estimates. The number eight is the estimating manuals. Okay, or we can use this one as we have the tools used in estimating, especially in using computer aided applications. Okay, so for LS1, we have the conceptual estimate. Okay, so introduction. The conceptual estimate is an estimate prepared by using engineering concepts and avoiding the counting of individual pieces. Okay, so conceptual estimates are generally made in the early phases of project. Okay, so before construction drawings are completed, often before they are had hardly begin. Okay, so then therefore, a cost estimator prefers a conceptual estimate with limited information scope and limited design engineering depth. Okay, so in every construction company, even big companies, cost estimator are always present. Okay, so they are the one who are preparing the cost of the certain projects. Okay, so it will be the deciding factor of the management of the company on how they will go or what are the uh, strategies that they will make to make the project more, let us say, profitable or more convenient to work. Okay, then to develop appropriate estimates using conceptual estimating, an estimator needs considerable skills, experience, and judgment. This is because they are the one who are providing the cost of every project. Okay, so we are now on our first topic. We have the conceptual cost estimating basics. Okay, so in everything that we need to do, or let us say activities, basic is very important. Okay, so we have to be familiarized with this one, basic, so that we can do this conceptual estimate more, let us say, good, or we have a better uh, way of preparing this let us say documentary requirement for a certain project. Okay. So conceptual estimating is an important pre-design planning process. Okay, so we all know this one. Okay, because we cannot decide, or management cannot decide uh, what the strategies that they will put into that project. Okay, so that what I discussed a while ago. Okay, then the following subsections present the conceptual cost estimating, definition characteristics, importance, preparation process, and outputs. Okay, so under conceptual cost basic, so we have I think three subtopics for this one, and the first one is the characteristic of conceptual estimate. Okay, so a conceptual estimate is an estimate prepared by using engineering concepts and avoiding the counting of individual pieces. Okay, so this is more uh, fast than a detailed estimate. Okay, so if you are, let us say, talking to a certain client first, so you need to have a bit, let us say, a forecasted cost for the client. Okay, so you need to tell him what is the probable cost of that project. Okay, as the name implies, conceptual estimates are generally made in the early phases of the project. Then, before construction drawings are completed, then before they are hardly okay, the first function of conceptual estimate is to tell the owner about the anticipated cost. Okay, so that's presenting owner or client. Okay, then that's presenting useful information for the owner in contemplating the project feasibility and further development. Conceptual cost estimating is defined as the forecast of project cost that is performed before any significant amount of information available. Okay, so next, under the basics of conceptual estimate, we have the characteristics of conceptual estimate. Okay, so we have one is the inexactness in the process. Okay, so with the absence of data and with shortage of time, there may be no other way to evaluate the science but to use opinion. Okay, so that is why in conceptual estimate, experience is very important in your judgment in the cost. Okay, so that is why some cost estimator, let us say, uh, the and big companies, they are relying on the senior estimators. Okay, so because they are the one who knows the cost of the previous projects. Okay, so and it's good that estimators also have experience in the field. Okay, so on what are the are estimated. So number two, we have accuracy and validity are highly related to the level of information provided by the project scope. Then we have resource restricted activity. The main resources for conceptual estimating are information, time, and cost. Due to the fact that conceptual estimating is performed in the early stages of the project, the scope information available is usually restricted in detail as well as in precision. Okay, so we have the number three, the important of conceptual cost estimates. Okay, so this is the let us say the advantages or the things that we need to know how important the conceptual estimate on the engineers, okay, or contractors in the field of construction. Okay, so preliminary estimates assist the overall cost control program, okay, by serving as a first check against the budget. Okay, so in project, uh, estimating is not the end of the line. Okay, so we have also the cost control. Okay, so this is on the pieces of the construction. So we need to control our financial capabilities of the project because the company is always take into consideration if the owner is or the owner of the company or the management is losing or gaining to this project. Okay, so it will indicate the cost overruns early enough to the project team to review the design for possible alternates. Okay, so this is what I mentioned. We need to the management or the team need to know the status of the project so that they can make let us say intervention, okay, to heal or to make the if there is something wrong and to make that one right. Okay, so next is the preparation of conceptual cost estimates. A generic conceptual cost estimating preparation is as stated in 1.1. The preparation begins with a request made by the management to estimate the cost of a new project. The most important part of the request is a project scope. Okay, so the project scope is the things that you need to deliver in the project. Okay, so that is why if you are a engineer in the field, you need to know your scope of work. Okay, so if you are uh, studying now, so you if you are on the field of the construction, you always hear the word, what is our scope of work this project? Okay, so you need to know that one because remember that in every activity, it incorporates a certain cost. Okay, so that is why you need to know your scope so that you will do only what is on your scope of work. Okay, so that is one to minimize your cost, excess cost on your project, and wastage of money on the part of the owner or management. Okay, so the first task of the estimator is to study and interpret the project scope and produce an estimating plan. Okay, so the next task is to collect historical data related to similar past projects. Okay, so this is on the conceptual estimate, guys. Then the selection and usage of this data is crucial for the estimating preparations because inappropriate information will negatively affect the estimate. Okay, so that is why in construction companies, they always they always keep the record of their previous projects. Okay, so this is the reason so that they have a basis on their future projects or let us say uh, possible activities that they need to do. Okay, so to prepare an elemental cost plan, the following information should be assembled. Okay, number one is we have the cost analysis of a previous similar building. Okay, so example, if you have a history of making a let us say a basketball court, then after 5 years, there's a certain client uh, wanted to build that one. So if you are in a hurry and your time is limited, you can use the historical data or cost, provided that you will consider the time. Okay, so because the time is important in estimating because after 5 years, usually the labor cost and material cost increases. Okay, so there are things that you need to consider in preparing conceptual estimates. Okay, so that is why you need to be careful. Okay, so sketch plans and elevations of the proposed project. Okay, so these are the plans. You need to see that one in estimate. So the main ingredients of a good estimate is basically the plan. Okay, so you because you cannot quantify or measure what you need to estimate. Okay, so you can estimate without a plan. So that's the rule of estimates. Okay, then outline specification level or services solution instead of the proposed project. Okay, we have the number 5, conceptual cost estimating output. The primary output of the cost estimating effort is the cost estimate. The estimate is typically expressed in unit cost. Okay? Then alternative units can be work quantities, material quantities, or staff work hours. Okay, so we have the 1.2 of this learning session, the broad scope of conceptual estimates. Prior the design of project, cost estimate could be prepared based on the cost information on previously completed projects. Okay, so similar to the purpose project. The number of units or size of project is the only available information. Then the unit cost should be developed from weighing the data that emphasizes the average value. It should be account for the extreme maximum and minimum values. Okay, so this is the formula used in the conceptual estimate. So we cost data from previous project. So see, okay, so as you can see, this is the unit cost equal to A is the minimum cost of the previous project. Then we have 4. This is in the formula. Then B is the average unit cost of previous project. And C is the maximum. You have to add these 3, then divided by this 1 to 6. Okay, so you will now get your forecasted or the forecasted units cost of that project. Okay, so now we are on the example. Okay, so use the weighted unit cost to determine the conceptual cost estimate. For a proposed parking that is to contain 135 parked cars. Okay, so this is based on their company data. So this they have same project before, a parking lot, and this is their data. We have 8 projects. Okay, so this is a lot. Okay, so it's a big company. Then with this the cost of the projects, then the number of cars. Okay, so as you can see, the higher the number of cars, capacity of the parking, the higher the cost. Okay, so you need to use this data to come up with the ideal or realistic conceptual estimate. Okay. Okay, so this is the solution. The unit cost per car can be calculated. Okay, so this is the table. Okay, so in here you can see 3110.4. To get this one, you have to just this is the cost, divide that one to the number of cars. Okay, so for 66580 divided by 150, the answer for that one is 310.4. Okay, so you can do that one until the 8th project. Then this is the unit cost per car. Okay, because you are dividing the cost in the number of cars, so you will be getting unit cost per car. Okay, so this is now our data. This is a important data in this system. Okay, so then the average unit cost for this one is 3431.5 divided by 8. Okay, so you have to add this one, divided by the number of project. Then you have the average unit cost of 3803.94 per car. Okay, so I think we have the data we need to complete or satisfy this formula. We have a minimum cost, we have the maximum, and we have the average. Okay, then we can continue. So the minimum is we have 2987. So this one, we have the error in the putting of numbers. Okay, so plus 4 times 3803 is the average. So this one, then this one is the maximum. So as you can see, project number 3 is the maximum of 4375.8. Okay, then you have to calculate all this one, then the answer will be divided by 6 as per our formula. Then the answer is 3763.14. Okay, accordingly, the cost estimate for 135 cars parking. Okay, so this is no problem because you have to compute the conceptual estimate of a parking lot with a capacity of 135 cars. Then you have to multiply 3763.14 on the number of cars. Then this will be your estimate of for the project. You have 508,023. Okay, so that's how we use the historical data in the estimates, which is very useful in our field, in engineering field. Okay, so next. Okay, so we are now on the conceptual estimate adjustment. It is necessary for the estimator to adjust the cost information from previously completed projects for use in the preparation of a conceptual cost estimate for a proposed project. There should be adjustment for time, location, and size. Okay, adjustment for time. The use of cost information from a previous project to forecast the cost of the proposed project will not be reliable unless an adjustment is made proportional to the difference in time between the two projects. The adjustment should represent the relative inflation or depletion of cost with respect to time due to factors as labor rates, material costs, and interest rates. Okay, so this is I mentioned a while ago about uh, using historical data in your estimate. Then we have measures of changes in items such as location, building cost, or tender prices are performed using index numbers. Okay, so index numbers are a means of expressing data relative to a base year. Various organizations publish indices that show the economic trends on the construction industry with respect to time. Okay, then the estimator can use the change of value of an index between any 2 years to adjust past cost control and to forecast future project cost. Okay, so now we have the example number 2. Suppose the indices for building construction projects show these economic trends below. Okay, it is required to use the cost of 843,000 project completed last year to prepare a conceptual estimate for a project proposed for construction 3 years from now. Okay, so this is the trend. Okay, so what's our economic trends? So 3 years ago we have 358, then 2 years ago we have 359, then 1 year ago 367, and the current year is 378. Okay, solution. The equivalent interest rate can be calculated based on the change in the cost index during the 3-year period as follows. Okay, so for this one, we are using the 378 current year divided by uh, 358, this one in the last 3 years, then equal to 1 plus the interest, and we have the power of 3. Okay, so then I for this one is 1.83%. Okay, then accordingly, the cost of the project should be adjusted for time as follows. Okay, so this one, so we have 843,500. So this is the cost given in the example. Then you have to use the 1 plus 0.0183. I think this is of 4. Okay, to the power of 4. Okay, so the answer is 996. Okay, so this is now the cost of the project. Okay, so using this is based on the index of the interest. Okay, so next we have adjustment for location. We have tender price levels vary according to the region of the country where the work is carried out. Okay, so the adjustment should represent the relative difference in cost, material, equipment, and labor to locations. This says that show the relative difference in construction costs with respect to geographical location is usually published by many organizations. Okay, so we have number 3. Okay, so this is in terms of location. Suppose the indices for different location of construction costs are shown in table below. So this is the table. Uh, Suppose that the construction cost of the project completed city A is 357,200. It is required to prepare a conceptual estimate for a similar project proposed in a city D. Okay, so this is the city D. Then the index for the city D is 1.105. This is much higher than 1.025. So it means that the cost in city D is much higher than 8. Okay, so we need to consider this one in our estimates because there are locations that the materials are much higher. Okay, so this is what this technique talks about. Okay, so we have the solution. The cost of post project should be adjusted for location as follows. Okay, so we have it 7,200. Then this is the index of the two city, 105 and 1.025. Okay, so city D is the numerator, then A is the denominator. Okay, then you have to divide that one, then multiply that one, 2, 3, 7, 200. Okay, so this will be now the cost in that city, the city D. It is much higher than A. Okay, so next we have the adjustment for size. Okay, so the use of cost information from a previous project to forecast the cost of a future project will not be reliable unless an adjustment is made that represent the difference in size of the two projects. In general, the cost of a project is directly proportional to its size. The adjustment is generally a simple ratio of the size of the proposed project to the size of the previous project, from which the cost data are obtained. Okay? Then we have a combined adjustment. The conceptual cost estimate for a proposed project is prepared from post records of a project completed at a different time and at a different location with a different size. The estimator must adjust the previous cost information for the combination of time, location, and size. Okay, so we are now on example number 4. Use the time and location, and this is presented in table 1.3 to prepare the conceptual cost estimate for a building with 67,700 for a building is to be constructed 3 years from now in city B. A similar type of building of cost of 2,197,540 and contain 38,500 square meter. Okay, completed 2 years ago in CTE. Estimate the probable cost of the proposed building. Okay, so this will be our computation. The proposed cost we have the previous cost is this is 2,179,540. So this is the one. Then the time adjustment we have 1 plus 0.0183. Okay, so this is from the previous data. Then the for the location adjustment is 1.17 over 1.24. Then for the size adjustment, we have 62,700 divided by 38,500. Okay, so size is this one, the floor area. Okay, now our new cost for this project is 3,700,360. Okay, so we have interest, location, and size. Okay, so that's the time, location, and size. Okay, that's the thing that we need to consider in our estimate. Okay, so now we are on the unit cost adjustment. Okay, so although the total cost of the project will increase with size, the cost per unit may decrease. Okay, for example, the cost of an 1800 square meter house may be 535 per square meter, where as the cost of the 2200 square meter house of comparable construct will be only for 87 square meter. Okay. Okay, so this is because certain items such as furniture, garage, etc. are independent on the size of the project. Size adjustment of a project is unique to the type of project. The estimator must obtain cost records from previous projects and develop appropriate adjustment for his her particular project. Then we have the conceptual estimating techniques. Number one is interpolation. Interpolation is a technique used in the early stages of the design sequence when information of those projects in a short supply. It requires a good deal of skill and experience, and it's the process of adding in or deducting for the cost analysis to arrive at a certain budget of a new project. Therefore, in preparing a budget for a new project, assume cost analysis has been chosen as the basis of this. However, the cost analysis will contain items that are not required for the new project, and this must be deducted. For example, in the new project, the client wishes to exclude the installation of air conditioning from the estimate, and this will have to be deducted from the project. Okay, so that is called the scope of work. Okay, so that's why we need to know or understand our scope of work. But on the other hand, the client wishes to include CCTV throughout, and the cost of providing these must be collected and added in. It is important, as described later, to adjust cost to take account of differences in price levels. The process continues until all unidentified differences have been accounted for. Other credible approaches to approximate estimating are available to the quantity surveyor are the unit and square meter methods, generally used for preliminary estimates when firm information is scarce. Then we have approximate quantities and elemental cost planning for later stages estimates. Other approaches are often cited, most notably cubic meter and story inclusion methods, but the accuracy of these approaches are somewhat dubious, and they are seldom used in practice that are not considered here. The next is we have the unit method. The unit method is a single price rate method based upon the cost per functional unit of the building. A functional unit being, for example, a hotel bedroom. This method is often regarded as a way of making comparison between buildings in order to satisfy the design theme, and that costs are reasonable in relation to other buildings or is in similar nature. Okay, so it is not possible to adjust the single rate price, and therefore variable part groups. It is suitable for clients who specialize in one type of a project. For example, we have hotel or supermarket chains where it can be surprisingly accurate. Other examples where unit cost may apply are we have schools, okay, so cost per pupil. Then we have hospitals, cost per bed space. Okay, so we are now on example 1.5. Assume that the current cost for a 120 pupil school constructed for wood frame for a city is 1.2 million. We are asked, okay, so you are asked to develop an estimate for a 90 pupil school. Okay, so the first step is to separate the per unit cost. We have 1.2 divided by 120. Then you can now see the unit cost per pupil of 10,000. After the unit cost to the new school or your proposed project, you have 10,000 times 90, you have 900,000. Okay, so simple. So that's the estimate for this one. Then for 1.6, we have the current cost for a 100-bed hospital constructed is 1.25 million. We are asked to estimate a 125-bed hospital. The cost per bed is 1,250,000. Then we have to divide it by that one by 100. So you have now a unit cost of 12,500 per bed. Okay, so to get the new cost for your hospital, you you just multiply the 12.5 to the number of bed of your new project. Okay, so then this will be your conceptual estimate. Okay, then for a multi-story garage is for space for 500 cars. The construction cost was 3 million. What is the estimate for 450? Okay, so same thing. You have to get the unit cost 3 million divided by 500. Then you have unit cost for from a previous project, 6,000 per car. For your new project or new garage, just multiply 6,000 to the number of car Then you have now a new estimate of 2.27. Okay. Then we have a superficial method. The superficial method is a single price rate method based on the cost per square meter of the building. Okay, so the use of this method should be restricted to the early stages of the design sequence and is probably mostly frequently used method of approximate estimating. Its major advantage is that most public cost data is expressed in this form. Okay, so the method is quick and simple to use. Though, as in the case of the unit method, it is imperative to use data from similarly designed projects. Another advantage of the superficial method is that the unit of measurement is meaningful to both the client and design team. Okay, so although the area for this method is relatively easy to calculate, it does require skill in assessing the price rate. The rules for calculating the area are all measurements are taken from the face of external walls. Then we have no deduction is made for internal walls. Lift shafts or wheels, etc. Across internal floor area. Okay, so we have for different parts of the building, variant function. Then the areas are calculated separately. Then external works and non-standard items such as piling are calculated separately and then added into the estimates. Figures for specialist works may be available for subcontractors and specialist contractors. Then we have the approximate quantities. Approximated quantities are regarded as the most reliable and accurate method of estimating, provided that there is sufficient information to work on. Depending on the experience of the surveyor, measurement can be carried out fairly quickly using composite rates to save time. Okay, so the rules of measurement are simple, although it must be said they are not standardized and tend to vary slightly from one surveyor to another. One approach involves grouping together items corresponding to a sequence of operations and relating them to a common unit of measurement. Unlike the measurement for a bill of quantities where items are measured separately, composite rates are then built up from the data available in the office for the sequence operations. All measurements are taken as gross over all but very large openings. Initially, the composite rates require time to build up, but once calculated, they may be used in a variety of estimating needs. Okay, so we are now on the parametric cost estimating models. Okay, so the parametric model uses historical data, which is the basis of the model's predictive features. However, the characteristics that are input into the process are primarily based on the performance indicators such as speed, accuracy, tolerance, reliability, friendliness, error rate, and complexity of the environment of the deliveries. Parametric estimating is used primarily in software development and system development projects. Parametric estimating is usually from the software development and system development projects. Then models calculate the dependent variables cost the duration based on one or more independent variables. These independent variables are quantitative indices of performance and or physical attributes. Okay, the parametric model for a construction project would use the data provided by the user or on any or all of the following characteristics. We have project type, pre-material, exterior material, ground conditions, we have the desired floor space and roof type. Okay, so these are the things that we need to consider in the parametric model. Then using the general relationship developed between input and output variables, the model provides an estimate of some or all of the output variables. Okay, so the output variables include cost of the design process, cost of the structure, size of the major equipment, the optimum size of the construction crew, the size of the parking lot. We have the duration of the structure construction, then the duration of equipment installation, and the overall project duration. Okay, so I think we already discussed the brief information about the parametric discussion. So although the detailed discussion will be discussed on the LS2 about the parametric estimating. Okay, so I think we are done on the LS1, which is the uh, conceptual estimate. Okay, so I think that is all for learning session, man, and thank you for watching this video. I hope you learned something from this one, although maybe observe that I speak fast. Okay, so this is to save time for this learning session. Okay, so I hope you learned something and see you in the my next video on the learning session.